the graph of y equals f of x is transformed to that. When it's in y equals form, no one else can hear it, but her water bottle's going. Yeah, just like that. It wasn't really, it was more about. Okay, if it's in y equals, remember with the y's we keep and the x's we flip, right? But if it was in replacement notation, which was all, the y's were all on the right, left, am I right? On your left, and the x's were all on your right, then you would flip all of them, right? But it's already in y equals, so we know we have the graph was horizontally stretched by a factor of, wow, that didn't go well, 9, niner, this is going to always flip, and vertically stretched by a factor of 4, because, yeah, it doesn't flip, which is D, as in dog, or dad, or dollar bill, yo. Yeah. And hit. Oh, look how nice I was. I took the -1 out. I gave you a gift. You're welcome. It's called the present. Okay, so that was funny. No? Gift, present, yeah. All right, it's not funny. We have to explain it. So, if you have the negative taken out, then you have a 1 in front of the x. Remember I told you? So you have 2 rules. Get it in y equals, get a 1 in front of the x, correct? A lot of people will not spot that 3. They just kind of don't see it there. So, then they call me over and they're like, it doesn't move to 1 quadrant, Lepp. This is a lie. And I'm just like, you're missing something. And they're like, I am not. And then they get angry. Very angry. When you're angry on a test, think, are we missing something? Okay. All right. So, our mapping, xy becomes -x. And then I need to move 4 to the left, so -4. And I need to move 3 down, -3. When I do all that, where did I go to? Quadrant 1, 2, 3, 4. Where does it move to? 3. It's going to for sure have to move to 3 because we're going to be moving down, right? We're going to be either 3 or 4, and then you're moving 4 left, so it's going to be 3. Could you plug in? Should you plug in every single point, though? Should you? Yes, you should. You very well should, especially if it's a test that's worth marks. You don't want to go chancing it. There's not a time to chance. It's not a time to save your pencil, you know? So, great. So this is interval notation. The range of the graph is 4 to infinity, equal to. So another way that could have been written is y such that y is greater than or equal to 4. That's set notation. This is interval notation. You need to know the difference between the two, and you need to be able to do both. Because on a diploma, they can ask you for interval notation, or on a test, I can ask you for set notation. So you need to be able to know the difference. This is an interval because it's between 4 and infinity, so it's an interval. This is a set because you say the set of y such that y is greater than or equal to 4, and of those, y is an element of the reals. So it's the range. What affects range? Y's. What affects domain? X's. So, cool thing, if it's range, and everything they're giving you affects the x, stop doing work. Your range stays the exact same. Life is good. Don't overthink it, okay? So, if it's range, look and see if something's affecting the y's. If it is, yay, our range is changing. If it's all affecting x's, our range doesn't change. Circle the same range and move on. They can do that, right? To see if you actually know too. So, the graph of y equals f of x is stretched vertically about the x-axis by a factor of 2 and translated 9 units down. Now, my inequality sign will not flip because what did not happen? I didn't have a reflection. So remember that when you have reflections, not only do your numbers change, but if you were like this, greater than or equal to 4, let's say, you're going to be what now? Less than or equal to -4, right? So not only would it multiply the y's by -1, it would cause your inequality sign to flip. So don't forget about the inequality sign flipping. Most people remember to apply it to the y, but forget to flip their inequality. All right. So we are going to multiply by 2. 8 times, or 4 times 2 is 8. And then we're going to move it 9 down, which takes us to -1. And our inequality sign did not flip, right? Because we didn't have a reflection. If I throw a reflection in there, I know I'm losing half the people usually on a test. I don't want to lose any of you. I want to keep you all. So we need to remember that when there's a reflection or inequality sign, it doesn't always flip, but most often it does. If it's an inequality sign, it will flip, but sometimes it's like YER. Does changing a whole graph when it's YER and flipping it change it? No, it's still be YER because you're multiplying everything by -1. Okay, this big kahuna question. The domain and range of the graph of the function of y equals f of x are respectively x is greater than or equal to p, x and on the reals, y is less than or equal to q. They say p and q can't be the same, p can't equal 0, q can't equal 0. So we could make them be something. So I know that they're elements of the reals, they can't be the same, and they can't be 0. So I'm going to let x be greater than or equal to 2, and I'm going to let y be less than or equal to 3. And from now until this question is done, I make p be a 2, and I make q be a 3. Remember I told you we have to remember we can actually replace the numbers with stuff, right? Because they tell us what stuff stands for. Do we have to do it this way? No. We could do it without filling in numbers. That's the way we can check it. So, this affects my what? My, y values. But this is the domain, which affects my x's technically, right? So is that negative going to affect anything in my domain? Nope. So x is greater than or equal to 2, x is greater than or equal to 2. That one's golden. We're looking for the one that's incorrect. Now this one, the domain, -x. So what's it going to do? It's going to flip my inequality, and it's going to multiply my x's by -1. So this, I was x is greater than or equal to 2. It's now going to be x is less than or equal to -2 or -p, right? So this one's incorrect. They didn't multiply the negative. This one here, both are being negated, but I'm just looking at the range, so I only care that my range is flipping and negating, right? So if my range is y is less than or equal to q or y is less than or equal to 3, it's going to be y is greater than or equal to -3. You have to remember to apply that negative, right? And then this one, you don't have a clue because this is our next lesson, inverses. Good thing it's not that one. So it's 2. Okay? Makes sense? So you have to flip it and negate it. Then we have this one. The graph of f of x is transformed. The new graph is g of x. So f of x is the brand new one, is the old one, and g of x is the transformed one. Now, we could literally just plug into mapping, couldn't we? And see which one gets us f, couldn't we? Or we could do a little narrowing down. So my g got narrower than my f vertically, didn't it? So I know that I'm going to need a vertical stretch that's less. So I know it's not going to be 2's. So these 2 are out. I've at least narrowed it down to mapping with 2. Right? Other thing is, I have a reflection. It was this way. It's now this way. So what reflection is that in? The y, correct? Because you were facing this direction, you were facing right, now you're facing left. So both of these have negatives. So that didn't narrow down anything. Okay? And then we have to figure out when we apply them, oh, this one has a negative for the y. Did it flip? No. Okay. Could you absolutely just plug in f and see which one gets you g? Yeah, please do it. Okay? You have to put on your mask. I'm going to give you a handout. So we have to be able to determine the equation of the transformed function. Okay? This is the one that people find the hardest to do. So I literally just take it out after we've done all our transformations and we go through the question together. Okay? And kind of do your homework here. So, what order do we have to do transformations in? We have to write them down in a certain order. We have to do them in a certain order. What order do we have to do? Yeah. Yes. So we do stretch, reflect, translate, correct? Stretch, reflect, we could technically do at the same time because they're both multiplication, correct? Whereas transformation we have to do last. So the way that we come up with the equations, and you have to pay attention or you're going to get it wrong every time, is you have to figure out your stretch, and if they reflected first, apply that, and then see how to move it on to the other one. Okay? So if you are stretching or reflect first. So let's look at F. F has a horizontal distance of what? At the bottom. 8. G has a horizontal distance of 7, 8. So did it horizontally stretch at all? Nope. So my B is going to remain a 1. Right? Let's look at our vertical stretch. F was 1, 2, 3, 4. It's now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know my B is 1. What's my A? A is 3, because I have to stretch it vertically by 3, right? All right, then we have to decide if there's reflections. Did this thing reflect? Make sure your phones are away. Did it reflect? Yeah, it was down. It now is up. Which axis is it reflecting on?
X.
The X, which means it applies to the Y. So my A is going to be a negative. Right? Now, does it reflect across the Y at all? It's a parabola. It's symmetrical, right? It's not going to really change. We can't really see it. So we think we've covered everything. We think that all there is on here is a vertical stretch by 3 and a reflection in the x-axis. We think that's all that's happening, right? And we'll know if we're right if when we go to apply those, we're actually going to get the exact same shape as g of x. It just won't be on top of it. It'll be translated somewhere, okay? So what we're going to do is we're going to use our mapping, x, y, and we're going to apply what we think has happened for stretches and reflections. So we think we're going to get this, minus 3y, right? That's what we think is going to happen. So we're going to apply it to the f graph and redraw the f graph. So we make an in-between graph. It's not going to be a g, it's not going to be f anymore. It's the in-between graph where we just apply the stretches and reflections to it. Okay? I'm going to make it green. So I'm going to plug in negative 4, 0. This is my in-between graph. And I get negative 4, negative 3 times 0, which is negative 4, 0. Why did it remain invariant? Why did it remain invariant? Because all I applied was a vertical stretch and a reflection, which means I multiply. That's all I'm doing. And y on those spots is 0. If I multiply by 0, what happens? Stays the same. And nothing happened to my x's, right? So then, indirectly, this one's going to stay the same, too. Then let's do 0, 4. It's going to become 0, negative 3 times 4. So I'm going to drop over the next graph. Don't do it, if I were you. Or you can, but make it light. So I'm going to go 0 and negative 12. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. I'm going to pretend it's here. Because I can erase, right? Would I need more points to make it more accurate? Sure. But does the green graph now look like the g of x graph? So then I know I'm right. I know I got all my stretches and reflections. If after I make that in-between graph, it looks the same as the g of x graph, it's just not on top of it, then I know I did good. I done good, kids. I done good. Okay? So it looks like g of x. So now all we have to do is apply our transformation. So these are the exact same graph now. I just need to make this one here move on top of here. Correct? And then the graphs would go on top of each other. So how do I get there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up. 1, 2, 3, 4, 5, 6, 7, 8 right. So how do I make my equation then? Well, I'm going to have y equals negative 3 f. My b, did it get anything? No, it's just a 1. X, I need to move 8 to the right, so what am I going to do? Subtract 8. And I need to move 10 up, so what am I going to do? Add 10. Now you should be able to check, because if you take that equation and turn it into mapping and apply it to the F graph, you should get the G graph, right? You should be able to check it. You can't type it into your calculator, because first off, we don't know the equation of the first one. And secondly, they have F's in them, right? So you can't type them into your calculator. So does that make sense? You need to figure out your stretches and reflections first. Apply them and get an in-between graph. And as long as that in-between graph actually looks like the transform graph, but it's not on top of it, then I can move it. That's my last step. You have to stretch and reflect first. So you're going to try B and C, and then we're going to go through them. You need B and C. Okay, we have to go from F to G. Horizontally, are they any wider from furthest point to furthest point? Are they any wider horizontally? Nope. Vertically? Yep. So if we go vertically, it's 1, 2, 3, 4, 5 originally. Now it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So vertically, I did what? Vertical stretch of 2. So we'll just write our translations on the side for now. Okay, so I know I have a vertical stretch. I know I don't have a horizontal stretch, right? It's just 1. Do I have any reflections? Yeah, the point was pointed down. The point is now pointed up. So if the point was pointed down and now it's pointed up, I'm reflecting on what axis? If the point was pointed down and now it's pointed up, which axis am I flipping over right now? The X, right? With my hand, I'm literally flipping over the X, correct? Point down, point up, point down, point up. I'm flipping over the X. Use your hand, it will help you. So I know I have a reflection in the X. Now I have to decide, do I have a reflection in the Y? I had flat line, peak. Flat line, peak. From left to right. Did it flip? No, I have a flat line and then a peak. I have a flat line and then a peak, right? From left to right. So it hasn't flipped left and right, has it? No. So all we have is these things to do to it. So currently, that mapping is x, y becomes, and both of those apply to my y, right? X negative 2y. So I'm going to apply it to my f. So I get negative 6, 4 becomes negative 6, negative 2 times 4. So negative 6, negative 8. And I'll know after this step if I screwed up, if it doesn't look like the G graph, right? So negative 6, negative 8, I'm here now. Okay, then I put in negative 2, 4. And it becomes negative 2 times 4, which is negative 2, negative 8. Connect. Then I have 1, 0. It's going to become 1, negative 2 times 0. It remains invariant because everything I was doing was multiplying by y, and y in that case is 0, right? So it's going to stay the same. Connect it. And then I have 4, 5, which is going to become 4, negative 2 times 5, which is 4, negative 10. Does it look like the exact same graph as G? Yeah, and if you don't know, count horizontally, count vertically. It should be the same thing. I have the tail and then the peak. I have a tail and then the peak when I go from left to right. So that looks good to me. Now I just need to move same point to same point. So I can move my far right point to my far right point. I can move my peak to my peak. It doesn't really matter as long as you move from the same point to the same point, right? So I'm going to go peak to peak. So from this peak, And remember, we're ultimately trying to land on g of x, right? So we're going to go from the graph we drew to g of x, because we're trying to land on g of x. So we don't ever go from g to the one we drew. We go from the one we drew to g, because we have to get ourselves still there. We're still not, we're close to getting to g, but we're not on g yet. So what else do we need to do? We need to 1, 2, go 2 up. And we need to go 1, 2, 3 right. And if we do that, we finally have landed on g. We agree? So then we plug it into the y equals a f b x minus c plus d equation. So I'm going to get y equals, I multiplied by -2, f, my b nothing happens, so I'm going to put a 1. I need to move 3 right, so I'm going to do x minus 3. And I need to move 2 up, plus 2. Okay? Then we go to our bottom one. It looks like it's horizontally wider, or narrower, sorry, and vertically narrower. That's what it looks like to me. Let's check it out. So horizontally, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It was 12. It's now 1, 2, 3, 4, 5, 6. So I have a horizontal stretch by what? It was 12. It's now 6. You can't say divided by 2. So what do you have to say? 1/2. Someone said it. I don't know who, but I heard it. Then vertically, we count our F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go. 1, 2, 3, 4, 5. We were at 10. We're now at 5. So once again, we also have a vertical stretch of a half. Correct? Now, what's the next thing we have to decide before we go move it? Reflections. Say we're like, I don't know what reflection it is. I can't do this now. Could you apply the stretches first, then see if they don't look the same as G, the shape, and then apply the reflections? Then make it look like G, then do the transformations, the translations? Absolutely. You could do it in 3 steps. There's no saying you have to do it in 2. You could do it in 3. You could move it, and then move it again, and then move it onto G. So, I'm going to look here, and I'm going to say, little peak on left, right? I have little peak on right. What does that cause me to flip in? The y, right? If I'm flipping from right to left, that's a flip in the y. So I know I have a reflection in the y. Now, do I also have a reflection in the x? I don't know. Let's look at the big peak. Big peak pointed up. Big peak pointed down. I also have a reflection in the x as well. So my mapping, xy, is going to become, I do what I say, right? So if I have halves in my words, I have halves in my mapping, right? It's only when I go back to the equation that they're going to flip. So I have 1/2, -1/2 x, comma -1/2 y. So I get, what the heck am I doing? I have -4/2. It's going to become -1/2 times 4, -1/2 times 2, -4, sorry. So it's going to become 2 and -1. Then I have -6. Try again. 0 and -6. -1/2 times 0. -1/2 times 6. So I'm going to get 0 and -3. Why didn't it remain invariant this time? Yeah, I wrote that. Why didn't it remain invariant this time? My x was 0. Was I only applying stuff to my x? No. Remember that it remains invariant if all you're doing is applying stuff to your x and your x is 0. The moment you apply stuff to your y, you're moving it off, right? Then we have 4, 4. Get negative a half times 4, negative a half times 4. So we get negative 2, negative 2. And then 8, 0. Negative a half times 8, comma negative a half times 0. Let's be negative 4, 0. Does it look the same shape as G? Yep. So we know we did good. If it doesn't look the same shape as G, we don't have to go back right to the beginning. We just have to figure out, oh, maybe I'm missing a reflection. So apply the reflection to it, make a new graph, then move it. You don't have to start right at the beginning again, unless you really want. Okay, now I have to move same point to same point. So I'm going to move this one to this one, because I feel like it. But you could have moved peak to peak, right? It doesn't matter. So I'm going to go 1, 2, 3, 4 left. 1, 2, 3, 4, 5, 6, 7 up. Now, these ones are easier because does my original graph have any transformations on it? No, it's a blank equation, right? If it's a blank equation, we can fill right in A, B, C, D. If our original graph, however, had transformations first, and we applied it to them, we'd have to keep it on the Y and then apply it to the whole thing. We'd have to do replacement notation. If you had an original transformed graph equation and you were transforming it, which we're going to deal with those after this. So we're going to have Y equals vertical stretch of a half and a reflection, so negative a half. F, my horizontal always flips, right? So I'm going to get negative 2, X, 4 left, so plus 4, and then D plus 7. Okay? Now on the back of your sheet, you have a complete blank sheet. We're going to get you to flip over to that. And I'm going to explain to you what I mean by starting with a transformed equation, getting a new one. Okay? So we're going to do a basic one where we don't start with a transformed first. So say I just give you y equals f of x. This is going to be your first equation. So we are going to determine the transformed equations. That's what we're going to do the whole time. So we're going to do y equals f of x if it undergoes a vertical stretch by a factor of 3 about the x-axis a horizontal stretch by a factor of 1/2 about the y-axis. A reflection in the x-axis vertical translation two up and horizontal translation three right. Was my original transform? Or was it just y equals f of x? What does it say? Y equals f of x, right? So I have no transformations on it. So that means you can apply everything directly to the right-hand side and you will be okay. So I could go y equals, I have a vertical stretch by a factor of 3, so I've put in a 3, right? I have an f. I have a horizontal stretch by a factor of a half, so what do I put in the equation? 2. Then I go and make myself brackets because I want to have a 1 in front of my x, correct? I have a reflection in the x, so which does that apply to, the 3 or the 2? The 3. Horizontal or vertical translation 2 up, so I can go plus 2. Horizontal translation 3 right, x minus 3. Very easy question if you have all your stuff memorized, because I can just plug it all in, right? So now we're going to do version A, or version 1.0, 1.5. This is 1. We're going to do 1.5. Because we're using the exact same transformations from above, but I'm giving you a different original. So I'm going to call it 1.5, so you don't have to rewrite out the transformations. That's just being lazy. If you don't want to be lazy, you can rewrite it and call it 2, if you really want to. I'm lazy. I'm going to call it 1.5. All right. So question 1.5. My original this time is y equals 2 f x minus 6. Apply the transformations to that equation. Okay, you can do this question one of 2 ways. I'll show you the way where you would just apply it to the equation all on the right, and then I'll show you how you could use replacement notation and move it over. Either way, as long as you get the same answer that's mine, you're good. So I'm going to apply it all to the right correctly. So we have to do our stretch, reflect, then translates, right? That's what we said. There's no other option between that, is there? We're doing stretch, reflect, translate. Why? Because we're doing bed mass. Stretch, reflect, multiply, and then translate, add, subtract. So that's how we have to do the multiplication first, then the subtraction or addition. So I know that I'm vertically stretching by a factor of 3, and I'm also multiplying by -3. We agree? Every y in my graph will be multiplied by -3. Every y. We agree? So that means every y in my equation as well, guys, needs to be multiplied by -3. Every y. So in this equation, this is a y, but also that is a y. And 90% of you, I will hazard to guess to say 96% of you will not have applied it to the -6. But it needs to be. You're stretching all the y's by -3. So if you went to go put a stretch in first, you would have to go, if you're doing this on the right, you'd have to go -3, this whole thing in brackets. So you would get -6 f of x times 8 plus 18, right? I also need to apply my horizontal stretches in there, which I did not do, which was a half. So I would also get y equals -6 f 2x plus 18. So now I've applied all my stretches. We agree? Yes? Now I can apply my translation. So I'm going to vertically translate it 2 up. So it's actually going to be 20, right? Y equals -6 f, I'm going to leave that for a second, plus 20. My horizontal translation, I have to go 2, and then I have to go in a bracket, don't I? Because I need to have a 1 in front of my x in order to apply my horizontal translation, which is 3 to the right. So now I'm going to go 1x minus 3. Do I technically need the 1 in front of the x? No, I'm just proving a point. And that's the correct equation. When people apply it directly to the right, they often forget to apply the stretch vertically and the reflection vertical to that translation. That's number 1 error. Okay, we don't want you to have that error. If I do it in replacement notation, I would replace everything. So when I replace, I do the complete opposite. So I have vertical stretch by a factor of 3. I would multiply my y by negative a third on the left. I would do like I do to my x, everything opposite, because when it's with the variable, it's actually the opposite. And then I have to move, 2 up, so I'm going to go y minus 2. So if I use replacement and it's on the left, I just literally flip everything like I would with an x. And then I'm going to go 2f. My x is going to get replaced with 2x minus 6. So I replace my x completely, I replace my y completely. And then I move everything. I could use replacement notation instead of applying it in steps. So now I would multiply by negative 3 each term, which is this term. This is one term, and so is this. So now I get y minus 2 equals negative 6f of 2x plus 18. And then what would I do? Add 2. Y equals negative 6f of 2x plus 20. I forgot to put in the stinking horizontal translation. I should have put it in up here. I'll put it back. So you would literally put your stuff in all at once to the original, replace it right off the bat, and then move it all to y equals. Did it get me the same answer in the end? Yes. So do I care which one you do? No. What do I care about is if you don't do it right. If you do this one, which most people will pick the first version and then work their way through, totally fine. But if you forget to take that stretch and multiply it by your translation at the back, you're wrong every single time. So both of these are completely correct and both get the exact same answer. You just need to pick which one you're going to be more comfortable with and do it. Because all that matters is that you get the right answer. Okay? Make sense? Your homework, I'm going to post it. Your homework is going to be to start working on your hand-in. So in your hand-in, paying attention, in your hand-in, you're going to have inverses, which we're doing tomorrow. So if you see anything with f negative 1x, or you see anything with inverse, with the word inverse in it, or you see anything with x equals f of y, don't do it. Or if it says reflection, that's not at all an F, reflection in the line y equals x. Any of these 4 things, you just can't do it yet. You'll be able to after tomorrow. But I want you to do your work on your hand-in tonight, because those are the hard diploma style, right? Like you can understand all your material, and then you get to the diploma style, and you might be like, I don't even know what to do first. So we need practice with that. So when the unit test hits, which remember we're doing transformations and polynomials together, then unit test, I still want that hand-in done before polynomials. Okay? We're still going to review that stuff. So you're going to work on the hand-in. I'm going to post it